So, next topic, which is transplantation, is just general ideas behind it, reactions. So it's really hard to say whether we should put it in a hypersensitivities or immunosuppression, because people who get transplants have to be immunosuppressed. So transplants or grafts can be classified into 4 different categories. Autograft, which is self-transplantation, for instance, skin fragment that goes on the burr, okay? In this case, rejection is not an issue at all. Then we have isografts, transplantation between identical twins, since they are genetically identical. They have the same MHC haplotypes, okay? So essentially the MHC molecules do not engage into the rejection. So if you have an identical twin, I suggest put them in the basement, feed them well. They will be an invaluable source of organs later in life. Do it first, otherwise they'll do it. Allografts, any other human, except identical twin. So it does not matter if we're talking about 2 strangers, brothers, sisters, parents, kids, does not matter. Usually, of course, due to the genetics, within the family, the matching is closer. Does that make sense? But often, it's kind of impossible. Okay. Xenograft, it's pretty straightforward. Animal. We do xenografts for cardiac valves. Okay, good so far? Now, what are the main problems for transplantation? First problem is rejection. So in rejection, and it's for solid transplants. So white blood cells, more specifically, usually T cells, mostly T cells, of the recipient attack the graft. Okay, so it all can be very easily explained if you remember a major histocompatibility complex story. So the graft has MHC that presents graft antigen. Does that make sense? While the recipient T cells are trained to see the recipient antigen. They mismatched. Does that make sense? So that's it. This is why people who receive transplant have to be immunosuppressed. Okay. Of course, better matching plays a role. Now, kind of the opposite situation will occur, so-called graft versus host disease, or Gvhd, in case of bone marrow transplant. It will occur when white blood cells, again, mostly T cells, of a graft attack recipient's tissues. Which kind of makes sense, because one of the main principles of transplantation, as you can imagine, you have to remove the organ before you put in the new one. So you remove all the bone marrow. Well, you not physically remove it, you kill it with radiation. So a person who receives the graft has no immune system whatsoever. So when new bone marrow is transplanted, new bone marrow starts to make white blood cells. And those white blood cells, they pop in the environment, which for them is completely foreign. And they just attack all the tissues. As you can imagine, this was learned the hard way. First bone marrow transplantations were done before we knew about MHC molecules and about antigen matching. So people who received first bone marrow transplants died pretty terrible death in a month or two after the transplantations. Basically, multi-system failure. All organs fail. Okay. Make sense? Good? Okay. Now, immunodeficiencies kind of segues us into the HIV. There are two categories, general categories that I want you to know, and I want to be very clear. There are acquired immunodeficiencies like, well, AIDS, which is a result of HIV, cancer. You can put immunosuppression, mediated by drugs, look, chemotherapy, it is an acquired immunodeficiency, right? One of my favorite examples, we don't really pay attention to this, measles, is very immunosuppressive. It's a transient immunosuppression, but it results in transient acquired immunodeficiency. Measles replicates in B cells and wipes out the B cell component of the immune response for about 6 months. Okay, and then we have congenital. So congenital immunodeficiencies are the ones the person is born with. I have, I think, 4 or 5 on the list. I want you to know exactly 3 immunodeficiencies which are most common. So no B cells. It's A gamma globulinemia. It's no T cells. DiGeorge syndrome. Okay, DiGeorge syndrome is a multifaceted disease which involves various problems like developmental disabilities and so on. And no B, no T, or severe combined immunodeficiency, also known as boy in the bubble. Okay, that makes sense? Treatment includes usually bone marrow transplantation. People with A gamma globulinemia actually can live with regular IVIG infusions, intravenous immunoglobulins. Okay, we're good? Questions here? All right.